Have you ever felt like Python was speaking a foreign language? Trying to understand variables and variable types can feel like a confusing mess. You get a type error for no reason, you try to store data, and suddenly you need to import a module to get the current date. This confusion often boils down to many types of shortcuts in Python. Let's simplify and start with truly understanding variables and variable types, and then moving on to applying that to Python. I'm Larry Grinovich, and I started programming in 1977. I've seen variables implemented all kinds of ways, but here's the truth. Whether you're building a massive web app or just checking a checkbox in a no-code tool, you're only dealing with 6 core variable concepts. Forget the official Python documentation for a minute. We're cutting through the noise. We're going to master 5 simple data types that hold one piece of information, and a single powerful concept of collections that hold everything else. For each of these 6 types, we're going to follow a clear path. We'll nail down the concept, what it is and why it exists. We'll look at the most basic, clearest Python assignment to create it. And then we'll dive into an immediate use case, why you should use this particular variable and what you should use it for. If you're confused by Python variables or need to solidify your understanding before jumping into complex logic, this is the definitive guide. So let's start with the first one, the string. It holds text. Use it for names, addresses, and any sequence of characters enclosed in quotes. So if you'll notice, the basic Python assignment is like first name equals Larry inside quotes, last name equals Grinovich inside quotes. And then as a use case, you can oftentimes concatenate strings together. Now, some languages have a specific concatenate function that you have to call, but many of them you can just use the plus symbol. So first name plus a space plus last name, and that you set full name equal to that in Python. And then if you print full name, you'll see it equals Larry space Grinovich. Very easy. The next two are kind of difficult because they're different things, even though we oftentimes think of them as the same thing. And that is integers and floats or floating point numbers. So integers are storing anything that's a whole number, and a floating point number is anything with a decimal. So that's lots of decimal points, very small things, small numbers, or even money is normally a float. And occasionally you'll find languages that have actually a money designation, so it's always only 2 decimal points. So the basic assignment in Python works something like this, where you say total cost equals 500. So that would be an integer because it doesn't have a decimal point or anything to the right of the decimal point. Sales tax rate equals 0.08. And then what happens is when you go to use that, you have to understand that things are a little different in that the integer gets converted to a floating point number when you start doing math. So if you take total tax amount equals total cost times sales tax rate, the final price is going to equal the total cost plus the tax amount now that you just created. And so if you print tax amount, you'll see it says 4.0. And the final price is going to be 540.0.00. So what you have to keep in mind is some languages put a penalty on this Python, fortunately, doesn't not force you to have to convert things. It just automatically converts them. So it'll automatically convert an integer to a floating point number. Now, the next one is the Boolean. Think of it as a decision maker. It holds either a true or false value. It's the simplest way to kind of like do a if statement with a variable and hold the status of something. So if something's on or off, that sort of thing. So a Python example we could use is user is active equals true. Password is correct equals false. So the person is here and active. This is a user that should be able to log in, but they don't have the right password. And then we can execute logic on that. So if the user is active, then we're going to print welcome back, else the account is suspended. Now, when you get to dates and times, some languages separate them, and they give you one variable type for dates, another one for times, and then they have a third one oftentimes for date and time. Python does everything as simply a date time variable, but the difference is that Python treats them as objects. And so in order to use them as an object, you have to import a date time module in order to actually work with dates and times. So that import looks like import date time at the beginning of your piece of code, not necessarily your function, but the overall piece of code. And then you would have statements like today equals date time dot date dot today. Okay, because again, it's an object. So you're creating an object called today that holds this date time object that has a value of today. And then birthday, so date, time, and date might be 1979, January 15th. So when you assign a date in Python, one way to do it is you have to actually give the year, the month, and then the day in that order to a function, to the date function, then that converts it into a date time date. And then once you have that, now we can do the differences. We can do calculations. So we can say time difference equals today minus birthday. And then we could print then days since my birthday and print that time difference. So that's a nice shorthand. It can be used for some things. Other things are going to use some other date time functions. So just be aware of that. So now the sixth concept I want to talk about, which is the hardest one, is the concept of collections. So various languages handle them different ways. Some call them arrays. Some call them actually collections. Others call them dictionaries, sets. But think of them as a matrix. So think of them as a spreadsheet where you have, you start with 0 and 0, 1, 2, 3, rather than one starting with numbers and going down. Instead of across the top, ABC, you have 0, 1, 2 across. And then you have this matrix that you then find values in. So every variable in here, whether it's a string or it's a number, is going to be at the location of this cross-referenced matrix. So in Python, the way we would create that matrix that you just saw was creating an inventory matrix variable. And you can also assign and add to matrices. But something like apples is 50 and red. Bananas, 35.00 in yellow. Oranges, 60.00 and they're orange. Pears, 40.00 and they're yellow. and putting the 0.00 in the numbers makes them floating point numbers for the prices. So now that you have this matrix, now if you want to access one of those items, so for instance, item name is inventory matrix 1, 0, and price is inventory matrix 1, 1. If we go back to the original where we put them, row 1, column 0 is bananas. Row 1, column 1 is 35. And if you'll turn around and print that, you'll see that the item name that we loaded from matrix 1, 0 is bananas. What we put in the item price 1, 1 is the number 40. What you have to keep in mind when you're using an array, or in Python's case, a list, is that this is a matrix and it doesn't care what goes in those columns. There's no naming convention. There's no way to know what's in those columns. So normally if you're going to define a matrix, what you want to do is define what goes into each column and make sure you put that into a comment in your code. Another way to do this is also something that confuses a lot of people, is a tuple, T-U-P-L-E. It's a fixed version of a list. It can be loaded at runtime, but once created, it cannot be changed. And you would use this for data where you're going to load it one time, like maybe RGB values or database credentials or something, that you're going to load this thing one time and then it's never going to have things added to it. It's never going to have rows subtracted from it. It just is what it is. And it's a way to kind of look up and reference things. Another variation on the list is the set. And the way a set works is each member has to be unique. So it's unordered. It doesn't sort things in order, but it also makes sure that there are no duplicates in the set. So where a list could have multiple bananas, a set can only have one. So let's look at a Python example. So if all cities is Chicago, Austin, Chicago, Miami, Austin, and assuming that this is something that maybe we read in. So like we're looking at all the different cities that we've delivered to or we ship to. And we want to know whether a city is a new city or this is a city that we've already shipped to and we've already set up maybe established routes and that sort of thing. So we'd say unique city equals the set of all cities. And as soon as we use that word set in front of all cities, unique cities now has only one Chicago, one Miami, and one Austin. Then, if we take that same set and we say, if Miami in unique cities, so if Miami is in the unique cities array, which it is since we loaded it there, then we're going to print previous package shipped to Miami. So the way a set would work is it's kind of something where you have a bunch of values. They could be duplicates in there, but you only want you don't want any duplicates in this list. And so you can read through that list, load it all into a set. Whatever doesn't go into the set is a duplicate. And now you have all a series of unique values. And then if you want, you could then take those unique values in that set, load them into a list, and then sort them as you put them into the list. Now, the other option for a list is what Python calls a dictionary. Now, some languages use a dictionary in that they have a key, and based on that key, you look up all the values associated with that key. In Python, we actually just have a list, but we are able to give those column names. Remember I said that matrix, you need to say what those various columns are? Well, with a dictionary in Python, you're given the ability to actually give those columns names. So if we did something like user profiles, and we have the first would be ID 101. The person's name is Alice. They started column is going to be a date that they started. And so if we create a dictionary, we now have the ability to print by reference. Okay, so username equals user profile 1 name. Okay, so row 1, the name was Bob. And so if we print that out, we'll get Bob. But we also can do a search. And a search would look like this, where the ID I want to look up is 102. I could set the username to none or just not even define the username initially, as I have in this example. And then for profile in user profiles, if the profile ID is equal to the target ID, so if it equals 102, then I'm going to set the username to that profile name, and I'm going to do something called break. So you notice things are indented here, and then print is out. So this for loop keeps looping between all these lower levels until it's done. So if this is true, if it's not true, then there's no other level that's on the same level as the if, and it goes back up to the for, and it just keeps looping around. But then you would break, and then when you print the username, you would get Bob. So that would be another way to get Bob. It sounds like a lot more work than finding a matrix, but at the same time, in the matrix, you've got to know what the position is of Bob. So now that you understand some fundamental way variables are created in Python, let's look at some of the confusing shortcuts that I'm seeing that make it very difficult to understand. And I'm sure you'll invariably have some programmer somewhere use them on you. This is where clarity often is sacrificed for efficiency. And what I'm talking about specifically is multiple variable assignments. So normally when people teach Python and teach variables, they throw all these concepts together at one time. And if you don't separate them out and don't get real clear about the individual ones, when you start doing this kind of stuff where it's name, age, is active, 3 different variables, you can put an equal sign, and then you can put the values of those 3 variables to the right of that. So what we had before would have been 3 lines of code. Name equals Alice, age equals 30, is active equals true. You can put all in one line. Now, my recommendation is to never put it all in one line. It's too confusing. It might be shorthand. It might save you some lines of code, but readability is the most important thing when you're writing code. And so I would always recommend you put assignments 1 per line unless you have some overwhelming reason that you can't do it that way and you have to do it the other way. So I would just avoid that just for clarity. So now you possess the foundations. You don't have to memorize giant lists of types. You just need to ask 2 simple questions. Am I storing a single thing, text, a whole number, a decimal number, a true false value, or a time? And then what does that language call that particular thing? Or am I storing a collection? Do I need to access this thing by a position, or do I just need to access it by a label or a key? Master these 6 concepts, and you'll have mastered data in Python. If the simplified approach helped you, please hit the like button and subscribe for more common sense lessons. And let me know your thoughts and questions in the comments. By the way, which of the 6 types do you use the most in your projects?